Welcome to the Jacob Buehrer Show today. Today, I am so happy and delighted to be joined by Alan Eustace. Do I say it right?
Eustace, but close, very
Eustace.
close.
Who, let's just say, this man has done many incredible things, and let him introduce himself.
Hi, I'm Alan Eustace. It's a pleasure to be here. Thank you for inviting me. I think I have a bachelor's, master's, and PhD in computer science from University of Central Florida. I've been working in the tech field, since I graduated in 1984. I started out with Digital Western Research Lab, and then I moved on to that company got bought by Compaq, which got bought by HP. And in 2002, I decided to go to this little company called Google. And so I was there from 2002 to 2015 when I retired. But I think this is more about this side project I had while I was at Google to try to break the world record for the world's highest skydive, which we and the team successfully did in almost exactly, I think, 7 years ago, 2014, October 24th.
Wow. And I just want to say after this, to all our guests, if you did see the field exchange, you're going to also have to see this. Jump and watch the documentary on Netflix. It is wonderful. So first off, how did the thought come to mind? I'm going to do this. I mean, I looked at the photos and I can tell you just when you see the photos of how high you were and how it took you quite a while to get up there, and you could have pulled something on your side. So many people would have been like, I cannot do that. So how did you have the thought process to do that? I think it's incredible.
So I grew up in Florida. All of the space program was kind of in my backyard. My dad was an aerospace engineer, and we used to watch all the launches. And so I don't think there was a single kid growing up in the time that I was growing up in the 60s that didn't want to be an astronaut. I mean, that's what everybody wanted to do. And if you couldn't be an astronaut, you'd be an engineer because you at least try to support it. And so that's what I grew up with. And I never became an astronaut. I did eventually become a pilot, and I always loved model airplanes and things like that. I did learn to skydive when I was 18, and one of the things about skydiving is almost everybody thinks about Joe Kittinger's famous record. He was a pre-astronaut. He was testing suits that they were using for high altitude flight and things like that. Back in the late 50s, early 60s. And so everybody knew about that record. And I think everybody in the back of their mind thought, well, someday maybe I could do that. And so I went on to engineering school. I never never became an astronaut. But the thought of what's it like to be in the stratosphere, what's it like to look down on Earth, what's it like to have the darkness of space, what's it like to see the curvature of the atmosphere, those things never really went away. And then Red Bull started to do their attempt, and it was well publicized that they were working on it. And I looked at what they did, and I just, they had a capsule that weighed 3,200 pounds, which is a giant capsule. And I always thought to myself, well, why do that? Why have a giant capsule? Why not just do more like scuba diving, where you can put your oxygen and your heaters and stuff on your chest, and then you don't have to disconnect from a capsule. And there'd been a lot of accidents related to that in the past, and a lot of engineering difficulty. I said, let's just make it like skydiving. You put your oxygen on the front, you put your heaters on your front, you get a normal tandem parachute, you hook all that stuff up to the front, find a spacesuit, go up into space, drop it out. How hard could it possibly be? And so that's how it started. And I studied it for a long time and tried to figure out whether it was technically feasible. And then, maybe a couple of years after I looked at it, I made a call to a guy named Tamer McCallum, and I said, "Hey, is this possible?" And he, his company specialized in, environmental systems for spacecraft and toxic environment suits. And after about an hour of really, kind of geeking out, he said, "Not only is it possible, but I would love to have my company involved in an attempt to do this." And so we have a friendship that exists to this day. And he put together a team, and we worked on getting the right people involved in the project. And almost 3 years to the day from the time we started it, we completed the record attempt in Roswell. So it was a fun time, really fun time.
Wow. And what was it like? So after, of course, he's like, "Yeah, we can do it. You know, let's go for it." What was that like? Because it's not just okay, let's do this, and 2 days later you're doing it. What was the process like?
Well, I started out with a set of ideas, and quickly we found out that some of those ideas weren't very good. There were some things like you can't just hook oxygen tanks on the front of a tandem rig. That doesn't work. Spacesuits are actually very complex and difficult to design, and the interfaces between spacesuits and other things you have to think about. And so we quickly figured out some things that were going to work well in the ideas that I had, and some things that were going to work well. And then we brought in experts in things like balloons and aeromedical, and they made some changes into what the plan was. And of course, it was always way harder than you thought. It was going to be way more expensive than you thought. It was going to be way harder than you thought. But I've talked to a lot of different people, and when they finish a project like this, they say, if I knew how hard it was, I probably would have never started it. And I think that's true. The process where you try things and they don't work, and you try other things and don't work, and you bring really smart people together to try to solve particular things. In some sense, the problem solving part and the teamwork parts are as fun as everything else, including the jump itself. And we had some really, really cool solutions to some of the engineering problems. Came up with some ideas that I don't think anybody had ever thought about before, and they turned out to be super valuable.
And what would you say what was the training like for necessarily? Of course, I mean it's I mean I watched the video, I watched the documentary, but some other people maybe haven't. So what is the training like?
Well, it depends. I mean, there's a lot of tests. I mean, probably 250 tests. Not all of them involve me, um, but there were a lot of them that involved me. And so, what you would do is they would have a test, they would plan it, they would have what they plan on learning on the test, what are the difficulties associated with the things that, might work out, might not work out in the test. And so the test would be very well developed and very well prepared. And so then I would come in on the test, both in the test planning, and then if the test involved me, it would be, okay, Alan, we want you to do the following 6 things. Like, let's give an example, like the temperature test. So it's going to be like, minus 120 degrees Fahrenheit, up there. So how do we test to make sure that you can stay warm enough in that environment? So, the team came up with, well, let's put them in a really cold environment and see how everything holds up, and how the heaters work, how the batteries work, and things like that. So, they ordered a giant refrigerator, a walk-in refrigerator, and they hooked it up to a liquid nitrogen tank with a big, handle to turn, and fans on the inside. And they figured out that they could actually get me down to the same temperatures that I would see, potentially in on this flight. And so then we tested. We put up a bunch of monitors, and we'd see how everything worked out. This one was kind of funny because it took 4 times to test it. There was a lot of problems on trying to get past this test. But in the actual flight, we turned off the heaters at like 70,000 feet because they weren't necessary, because it was super cold, no doubt about it. But there were so few molecules up there that the cold couldn't really conduct with the rest of the suit. And so it was actually, the temperatures were super nice at 70,000 feet and above. And I didn't have to go through any of the very difficult things that we saw in the test. But anyway, that was just one of many tests, to try to make sure that our engineering things that we had on paper actually turn out the same in real life. And some things we learned about that they didn't. Spins were an example.
Interesting. So then, of course, after all those tests were successful and you were finally ready to go, what was that like for you? Of course, the days before, I know there was cancellation at one point and you had to suspend it. What was that all like? And then the night of and getting ready for all that, because it's a long process.
Yeah, so most of the tests were on the ground, and then we ended up trying to get to airplane jumps. And so you go through the process of doing multiple airplane jumps, and the idea is to make sure that the suit performs well, the oxygen systems run well, the heating performs well, that you can get to the handles, you can pull the handles, the parachute comes out, you can control the parachute. And if you've seen the Netflix, you know that we had a problem on jump number one. So I won't spoil that by telling everybody what that is, but that required us to rethink a lot of systems. But after the airplane jumps, you know, then the next part is you got to get higher. And the only way to get higher is with a balloon. You know, all this modern technology, we have to go all the way back to, you know, the 1700s and use a balloon. I mean, modern materials and stuff like that. But you know, so we have a balloon, and we had 3 balloon jumps, one at 57,000, one at 105,000, and one at in the record jump 135,800 890 feet. So you do the first one, you do the first one's the 57,000 feet, and you know the process is always the same. You're getting up in the middle of the night, your whole team's getting up in the middle of the night. You pre-breathe oxygen for some period of time. You're doing exercises while you're pre-breathing oxygen to get rid of nitrogen in your system. Then after that, you're going to get in the spacesuit, and you're going to have a team of people who are going to helping you, because it's not easy to get in a spacesuit. You certainly couldn't do it alone. And then to get in the spacesuit, then you're, in my case, I was hung from a front end loader and actually moved out to the balloon launch area. Meanwhile, the team's putting a balloon up in the air. They're getting it ready, filling it with helium. They're making sure that everything's set. And when everybody thinks it's safe, then you know, get wheeled underneath the balloon. You're connected up to a balloon. It takes about 10 seconds, one mechanical connection and one electrical connection. And you know, then as soon as everybody thinks that the balloon is in the right position, you're launched. You know, which is basically just released. And you know, then you start ascending. You go up at, you know, 1,000 feet, 1,200 feet per minute the entire time. It doesn't slow down with altitude like airplanes do. And you know, you get to your jump altitude. The first one, it was funny. The first time we did the balloon, we hadn't even thought about a countdown yet. And you know, I get up there and I say, "Hey, Sebastian, you think we could do a countdown?" And he said, "Sure, I think we can arrange that." So the first one we did. It all worked fine. And the second one, we obviously every time you go higher, you're going to go faster. And you have a kind of a new set of issues, you know, temperature and things like that. So the 105,000 gave us a lot of confidence in a bunch of systems. And then we were ready for the 35,000 one. And the biggest change there was speed, because that was the first one we were going to break Mach 1. We were going to go faster than the speed of sound. And so there were some things that we had to work on. But boy, the training on the whole thing, you know, they'd be spinning around and had to do all this different stuff. I mean, I couldn't have been more prepared. You know, I had to basically grab reserve handles and main handles, and I had to deal with all these emergencies and malfunctions. And what happens if this happens? What happens if this happens? What happens if this happens? And you know, so it was grueling, you know, just physically grueling. I think one of the tests right before the last one, there was a progression. If this happens, you have to do this. But if that doesn't work, then you have to do this. And if that doesn't work, you have to do this. And they were spinning me around and shaking me up and down. And I was having to basically execute against that while I was getting, you know, practically getting sick at the same time. Later in the book, Jared points out that they were trying to get me sick, but thankfully they didn't succeed. But I did give up at some point, saying, "Hey, if we do this any longer, this spacesuit, it's not going to be pristine." Anyway, they called the test off. And thankfully, you know, as you always hope, you know, you want your testing to be more grueling than the actual event. You want the actual event to be, you know, peaceful and beautiful. And that's what it turned out.
Wow. So of course, what was it like when you're at 135,000 feet? I haven't been there. No one else has been there except you. I mean, the scenic route, of course, you said it was the most beautiful thing ever as you're going up. What is that like? I mean, is it scary at all? Because you know, like you can pull a handle and then go down. Is it like, what was that like for you? I mean, just going up there and seeing the world. I mean, you feel like you're in space. It's black all around you, and you literally have a wonderful view.
Yeah, it was serene. I mean, it wasn't scary to me at all. I mean, partly we had done the other trips up, which my heart rate was probably slightly higher, but I would say it was really serene. I just you know, it's kind of like Google Earth. I don't know if you've ever done that, where it zooms in real quickly. You know, it's kind of like the opposite. You know, you start out just looking at pebbles on the ground because you're literally a foot off the ground looking at pebbles, and then at launch you start getting up higher and you start, you know, looking at people and then cars and then buildings and then towns and then states and then, you know, I mean, you know, it's like The view just is just constantly expanding as you go up, and really super beautiful. And the atmosphere itself, as you get above the atmosphere or even go through it, you see all these beautiful layers in the atmosphere that you probably would never recognize before. And you get up and then to the darkness of space where you get this, you get this halo across the whole thing. And I don't know, it was just unbelievably pretty. And part of the time, what you're doing on the way up is you're practicing your emergency procedures, because that's pretty much all you have to do for 2 hours and 7 minutes. So you'd practice them, but I'd say 95% of the time I was just enjoying the view. And balloons are nice too, that they turn slowly. You don't have to do anything. They just slowly turn. So you would go around and, every 3 or 4 minutes, you would get a complete 360 of the entire world as you, kind of spiral up into the high altitude. So I can't think of a prettier, way to spend 2 hours and 7 minutes. And yeah, it gives you this great view and perspective about Earth. And then on the way down, totally different. The serenity is gone.
Now, before we get on to what it was like on the way down, what could you see visible when you were going up? Could you see the oceans?
Yeah, it was really interesting. I'm glad you brought it up,
How
because
far could you
I,
see?
I was trying to figure out how far you could actually see. Like, could I see the Gulf of Mexico? This was from New Mexico. Could I see the Rocky Mountains? And some things I knew I could see, like White Sands, Missile Range and stuff. That was easy to see. But I was trying to figure out what's the farthest thing I could see. And at the time, I didn't think I could see the Rocky Mountains, but it turns out I'm just so high that the Rocky Mountains don't really look like mountains anymore. They look mostly flat. So uh, you can't see the Gulf of Mexico. That's just too far away. It's actually, even at 135,000 feet, it's around the side of the curvature of the Earth. So you can't see that. I forget what the actual distance I could see, but one thing that it was really fun to do afterward is, now that I had the videos, so the movie has small amounts of video, but I have all the video. So I could actually take the video that was looking out from me the entire time, and I could play that video, and then I could actually see what direction I was going at that time. And then I could take Google Earth, which allows you to basically pick any place in space and do a 360. And I could now match up the scenery that I had seen at 135,000 with the actual scenery that Google Earth is projecting I can see at every one of those. So that was super fun. It was great. And that's where I learned that the Rocky Mountains were there. I just thought they were too small to think about them as mountains. But I could find out how far I could see, which was a considerable distance. There's just not many things that you can.
What states were visible?
All every state around me was visible. So I was well out of New Mexico. I was in I could see a big part of Texas. As a matter of fact, I think I might have even landed in Texas. It was certainly on the New Mexico-Texas border, because that was a 70-mile trip underneath a balloon before I released. So yeah, I could see Texas. I could definitely see, New Mexico, all the surrounding states, Colorado. You can see for a long way. It was impressive how far you could go.
Wow. And could you see any planes beneath you?
Well, there's not going to be any planes beneath me, because that really cool thing is we work with the FAA, and they actually established a corridor underneath me, so that if any minute I needed to do an emergency release, there would be no planes underneath me. So through that coordination, I had my own column of airspace all the way up. For 2 hours and 7 minutes, there was no plane directly below me, but there were planes all around. I mean, 10 miles away, but it would be fun to actually go back and see how many reported this strange giant balloon that was going up 10 miles. You should absolutely be able to see this balloon. We could see it from the ground the entire time. I mean, I couldn't see it because I wasn't there, but on some of the test jumps, you could see the balloon the entire time if you knew what you were looking for. So I bet there was a lot of sightings of that balloon. A lot of airplane pilots were probably going by and asking air traffic control, what was going on. But anyway, usually they don't know. So, yeah, there's probably thousands of people that saw it.
Interesting. Wow. So on a UFO report on that date in 2014, it was not a UFO, it was a person going up. So then what was it like?
Our launch was out of Roswell, by the way, New Mexico, which is, kind of alien central. And some of the early UFO reportings were probably balloons. So it could very well be. And there's even an alien museum in downtown Roswell that we had to make a pilgrimage to at one point. So yeah, there definitely could have been some UFO reports at the same time.
Now, one last question about what you could see. Could you see the space station by chance or no?
I wasn't really looking up that much. That would have been kind of directly above me, so I didn't know, but I'm sure I could have. I mean, if you can see it from the ground, you can definitely see it a lot better from space. It was really hard. Mostly I was looking down and out. I couldn't even see the balloon, honestly, above me, except I had a mirror, a curved mirror that was on the back of my left hand. And if I wanted to see the balloon, I had to actually look in this curved mirror, which was super fun because this curved mirror actually caused the load lines to actually spiral. So when I looked at in the mirror to see what the balloon looked like, it looked like some kind of abstract art. It was really beautiful. But anyway, couldn't see straight up. That wasn't part of the plan. Only on the way down did I get my first glimpse of the balloon.
Wow. So then what was it like? You're up there, they count down, and then you drop and you went past the speed of sound. What is that like?
So the release is done from the ground. So I put myself in the position that I think is, most likely to be the one that I'm going to want to be in. And they do a countdown and do the release. This one, none of the rest of them's happened, but on this one, I actually did backflip, like one backflip and almost a second backflip, which wasn't a problem because the systems that we had designed were perfectly capable of dealing with re-establishing a face down position because I have this amazing drogue system that we had designed. But it did give me a chance to see the balloon, which is the first time I'd ever seen the balloon. So because the previous ones I'd always been looking down. So as I flip, I see this monster balloon. And the cool thing about the balloons is that they get bigger and bigger as they go up because the pressure on the outside goes down and the pressure inside will match that. And so in the end, this balloon was 11 million cubic feet. And if you do the math, almost, every professional sports stadium in the world, basically pick one of them, and you could fit it inside this balloon. It's that big. And so, so I got to see it as I'm falling away and doing this little backflip. I can watch this thing, this, giant balloon receding away as I'm flipping through. So it was beautiful, but you're weightless. I mean, you're falling at exactly the speed of that gravity accelerates you, and there's no resistance. So that's the definition of weightless. So you are completely weightless as you're falling, which means whatever position you're in, if you're starting to do a turn, if you're flipping, you'll continue to flip because you're in a weightless environment. And then once the drogue starts to catch, so that's like the first 15 seconds. Once the drogue starts to catch up, and there's a little bit of drag in the drogue, it will flip you over and you'll be face to earth. But there's no sound still, even though you're falling face to earth, there's no sound because you're accelerating with essentially no resistance. And then I think it gets up to, I think you break the speed of sound about 40 seconds into the jump.
And you went at max, it was 822 miles an hour, if I'm correct?
Yeah, 822 miles an hour. That happens at about 50 seconds. And then you start to hear sound, and that means you're slowing down. And the whole rest of the time, you're decelerating. So by the time you get to opening altitude, which is about 10,000 feet above the ground, you're falling like a normal skydiver speed. You're falling 125 miles an hour. So you open your parachute and you descend a lot slower than you land. Or as you know, in my case, it was less of a landing and more of a crash, but maybe we'll get to that later.
Do you feel that you're going to speed of sound did you feel like you were going to speed of sound, or what did it feel like? I mean, you were inside of a spacesuit. No, you didn't?
No, I couldn't tell anything there. Matter of fact, I didn't know. I mean, we had already predicted I was going to break the speed of sound. And the speed is evident because it takes really small control movements to get, to stay on your heading and to be able to turn. So you have to be super careful about not, putting your hands out too far or something like that in order to maintain your heading. And so I know I'm going fast. There's no doubt about it because I know the reactions that I'm getting from just very small movements. So going fast, but I couldn't tell you at what moment I broke the speed of sound. There's no change. I couldn't even tell you what the fastest point in the whole thing was. It was only looking at the graphs on the ground and then matching it up with the video output that I actually saw exactly when I broke the speed of sound and exactly when, was my fastest point. So anyway, became an engineering problem on the ground. In the air, I didn't know anything.
Wow. And then what was it like what was it like landing?
So the landing was, I'm in a giant airbag, and we learned on the previous jumps, both the balloon jumps and in the airplane jumps, that landing in a spacesuit is not going to be easy. It's going to be, I'm, the spacesuit that Red Bull used basically depressurizes by the time it gets to landing, and it has, the arms and legs move. You can walk in it and things like that. This suit, I'm weighing a lot more. The suit doesn't move, so I'm gonna hit the ground hard. But the good news is that I'm surrounded by metal on the top and the bottom. So, and also I'm in a giant airbag, this beautiful airbag. So as long as I can, do a good job at flaring and reduce the speeds a little bit, I'm going to be fine. And that's what happened. Every jump was kind of a tumble forward, and I never got a scratch from any of them. So, but if you look at the video, it looks pretty darn exciting to hit the ground and flip over. But anyway, it was definitely something that that looked better in the movies and looked more intimidating. And in actual fact, there was nothing to it. It was very easy. I never even got a single scratch from any of the landings, regardless of how bad they looked.
Wow. Well, a few more questions I have is, how high do you think it would be possible for human or mankind to jump from?
So I had 11 million cubic foot balloon, and I weighed about, the whole system probably weighed about 600 pounds or something like that, which is what made it possible for me to exceed Felix's record by a lot, even though I was using a way smaller balloon. His balloon was 28 million cubic feet, mine was 11. And every time you double the size of the, every time you want to go up an additional 10,000 feet, you have to double the size of the balloon. So in that case, 11 million to 22 million should have gotten me another 10,000 feet, and 22 million to 28 should have gotten me a smaller amount. Let's call it 12,000 feet or something like that. So if my system with his balloon probably would be just shy of 150,000 feet.
So that'd be the max you'd say that the human body can
That's the
go.
max. That's the max with a balloon. Okay. Now, you could possibly cut out some weight, make it go a little higher than that, but somewhere less than 155 or something like that is a balloon. Now the question is, okay, well, let's say you don't use a balloon. Let's say you use a rocket. So, so then you could go straight up for farther. So at what point would that thermal heating on the descent and the speed on the descent cause you to start to have problems? And I think we did a back of the envelope that, maybe about 200,000 feet, maybe something like that. You're going fast enough for it to actually start to matter. And then the question, that I always had is, well, how about if you go out of a space station or something like that? And there was a Moose project back in the 1960s that talked about basically an emergency capsule that you basically can do. And so anyway, I looked into that just for fun. And, you obviously can't just use a spacesuit. The problem is not the height. The height is, height's bad, but the problem is how fast you're going. So if you're in orbit, you're going 17,000 miles an hour.
Yeah.
And the energy associated with that speed, it goes up by the mv squared. So, the speed is really a big problem. The height is also a problem, but not quite as bad of a problem. That's, mgh, the height, mass, times this, gravity times the height. But it's really the speed that's the problem. So you have to somehow basically reduce that energy. And so anyway, so I think it's possible though to build a custom. I'd build an inflatable system basically that it has a blade of material on the outside. And so when you release from the space station, you basically, put this blade of material around you, and then, let it pick up all the heat. And you got to make it glide. You don't want a ballistic reentry because it causes high G loadings and stuff like that. So it's got to have a little lift on it. So anyway, I think it's possible. I think someday somebody's gonna do a skydive from space.
Wow.
Probably not me. My wife would kill me. But yeah, there are no limits. You can. There are a lot of things that are possible out there.
Interesting. Wow. I don't know if it'll be me either. Uh, so would you say, and then also, would you ever want to go to space? Of course, right now, hey, a lot of people who like me were maybe not all A students couldn't get into Harvard. I won't be able to get into Harvard or anything, but would you ever be interested in going to space? Because now, Virgin Galactic, Blue Origin, uh, more opportunities are opening up more than ever. Would you ever consider going to space? Because you certainly wouldn't be scared to do it.
Yeah, no. Somebody once they reopened a few years back. They reopened the astronaut program, and some friends of mine were trying to get me to apply. And said, "Wow, who's got your experience? Why don't you put in an application to be an astronaut?" And I'm a little old to be an astronaut, honestly, but I thought it'd be a fun exercise to do. Uh, I love space. Someday I'd love to go into space. There's no doubt about it. But the thing that I loved even more than like the views in the space and stuff were technology. I'm a technologist. I'm an engineer. I love everything about the process of getting into space. I mean, just buying a ticket and sitting in a seat, for me isn't as exciting as being part of building something. So I don't think I'm going into space anytime soon. I'm actually looking a lot at autonomous vehicles for undersea exploration right now. So that's where I'm spending my time.
Interesting. And so, would you ever go down to the Mariana Trench potentially?
No, this is autonomous vehicles. My wife has kind of nixed the idea of me going down myself, but I'd love to basically be able to build a robotic vehicle that can explore the oceans in really interesting ways. So anyway, we'll see. Maybe in a year or two we'll get there. We have a small team. We're working on it. It's going well so far.
Interesting. Well, then I'll have to interview when you get back from that if you do it.
Okay, it's a deal.
One other thing. You are, of course, a former Google executive. What is it like working at the executive level in a company?
I mean, I enjoyed everything. I enjoyed being an individual contributor. I enjoyed having small teams. I enjoyed, managing, a small department. I enjoyed, managing all of engineering for a time at Google. They have their different sets of challenges, but they're always fun. I mean, the main thing about Google, which I really, really liked and appreciated, is that team that we built. I mean, it was incredible number of people, and we're also doing something that no one had ever done. No one had scaled, computer systems like we were trying to do. I mean, you're rarely given a problem where the demand is exponential, and you can plot it on log graph and see that, oh my gosh, given the growth rates, we're going to have to, in a month, we're going to have we're going to have to process double the number of queries that we had in before. And I mean, it's, you start out with, a single data center, and you move to multiple data centers. And before you know it, you have to build your own data centers. You just can't use it and thing. And then you have to build your own hardware, and then you have to build your own networks. And it's just an unending stream of problems that you have to solve in real time. And so I'll always cherish that time at Google. It was an amazing time, amazing team. And we cared deeply about solving the world's information problems, making, everybody who worked at it at the time probably still can just repeat, we're going to make, organize the world's information and make it universally accessible and useful. And we were all driven by that mission. And I had a great time. It was fabulous. I learned a lot from a lot of great people.
Wow. And then just my one last question really isn't a question. What advice would you have for next generation of people out there who want to do awesome things? Anything really. It could be being an astronaut. It could be maybe they're inspired to jump from the space station after they one day and try that, or anything. What would you say? Or they're scared of something. What would you say to them?
Yeah, I mean, for me, the biggest thing is you get some idea, some, crazy little thing, or you just get an idea to do something. Most people stop with the idea, it's kind of crazy, like, even simple things like, okay, I want to do a tandem skydive or something like that. Most people, have that idea, but they never follow up on it. They have a long list of list items, which are really not checking off, and so for me, I really feel like the most important thing is if you have some idea, any idea, you know, start on it. If you want to learn to play guitar, listen to people playing guitars, or buy a book on guitars, or read something about guitars, or learn the history of guitars, or listen to your friends play guitars, or rent a guitar. I mean, it's just, just make progress toward whatever goal you have. And the resources available right now are just unbelievable. So there's, when I was a kid, it would have been hard to find out about, things like, balloons and space and things like that. But with tools like Google and, other things, it's actually pretty easy to learn a lot in a hurry. And don't be intimidated by all these articles that you don't understand, or by written by all these people you don't know. Just keep plowing through it, and have a lot of perseverance. And there are very few goals that aren't achievable, nowadays. And it's really how bad you want something, rather than a lot of things that can potentially get in your way. So I laughed when you said, "Well, I'm not going to get into Harvard." It's like, well, I don't know. You're a 16. You got a year and a half to prove yourself. You already got this great podcast. You got a lot of
True.
things that other people don't have. You got contacts. You got people that have been on your show. Things like that. So I don't know. For me, that's the thing, is believe. Just believe in yourself. Believe in your ability to research. Believe in your ability to network, talk to other people, and slowly make progress against ambitious goals. And I feel like that's the best thing you can do. And never sell yourself short. You have a lot of potential.
Absolutely. Thank you so much for coming on. I really do appreciate it.
Oh, no problem at all. Thank